Hey everybody, we are going to go through the lesson 5 notes together. So make sure you write down everything that I do and hopefully you're listening to my explanations. So lesson 5 is called Congruence in Right Triangles. So the goal is still like to prove to somebody, or maybe say it's not possible to prove to somebody, if this triangle is the same as this one. This is our fifth and final like shortcut to showing someone that two triangles are the same. So before I kind of like explain to you what this shortcut looks like, we're going to investigate, which sounds thrilling. But we're being asked here, are these two triangles congruent? If you notice, and maybe you don't, but these triangles are a little bit different. They're a little bit more specific than a lot of the ones we've been seeing so far this unit. And this goes along with the title of the lesson here, but these two triangles are right triangles. Okay, so they have a right angle. We know a lot more, or I guess I should say, we have some tools for right triangles that we don't have for other triangles. We have Pythagorean theorem. So remember, a squared plus b squared equals c squared. We can use that to solve problems or find missing pieces, I should say, in right triangles. A and B are the legs, C is the hypotenuse, which is across from the right angle. So what I could do is I could be like, all right, well, I don't know, are these guys the same? I guess if I look at kind of the information I have and I think about the shortcuts we already know, I have an angle, a side, and a side. Same thing over here. I'm not even going to say it because this is being recorded, but if you see the order of the letters, that's ASS, and that doesn't work. So if I were to look at these triangles right now, I would say, I don't know. I don't know if they're the same. There's not enough information to lock in one of those shorter methods. But I could fill in this side B over here. I could find that missing side. So I'm going to use Pythagorean theorem, and I'm going to figure out what that missing side is because Pythagorean theorem helps me do that. Okay, so that's 16, 25. I'm going to subtract the 16 over right there, and that would be b squared equals 9. And then when I square root, because that's my last step, b equals 3. Square root of 9 is 3. So, okay, cool. This side is 3. If you guys look at the other triangle, I'm not going to waste my time doing Pythagorean theorem again. It's the same setup. I would still have, okay, this is C, the hypotenuse. So I'd still have like 4 squared plus b squared equals, or x, call it whatever you want, 5 squared. Okay, that's the exact same setup. It's going to be 3. So now if I look at this, I'm like, oh, I have a side that's the same, another side that's the same, another side that's the same. The sides of this triangle are the exact same as the sides of this triangle. So yes, I can say that these triangles are the same. So maybe let's like type a little note. Yes, they're the same. Let me say this. Side, side, side proves they are congruent. Okay, so it's the same triangle. Pythagorean theorem, right triangles. We just know a little bit more about them. Okay, so what's the point of that? Well, here's the point. We already have 4 shortcuts, so let's fill those in. Side, 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 angle, side, side, angle, and angle, angle, side. Like I said, this is the 5th shortcut. Now, this shortcut only applies to right triangles. So now here we go. We're going to write this in. This shortcut only applies to right triangles. So again, remind yourself, like these are the legs. We've learned this with Pythagorean theorem. Across from the right angle, that's the hypotenuse. Okay, so right triangles have like specific names for the different sides, legs and hypotenuse. Let's say legs. We cannot forget that. We need that background information because we're only talking about right triangles today. So, okay, well, once we got that down, what's this shortcut? Well, it's called hypotenuse leg theorem. Okay, so what it says is if the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, that's enough to say the triangles are the same. Okay, it's called HL theorem for a reason. Oop. We'll just leave that there. Okay, it's called HL theorem for a reason. Just like side SSS is side, side, side. You need all three sides to be the same. We're just going to say HL here. You need the hypotenuse and the legs to be congruent in a right triangle. That's exactly what's being shown down here. So these are right triangles. Cool. That's the first thing I need. This only works for right triangles. There is no hypotenuse if it's not a right triangle. I've got it. The hypotenuse are the same, and one of the legs, just one leg is the same. That's exactly what I need to use this thing. So those are the three things that have to happen for HL to apply. Got to be right triangles. You have to have the hypotenuse being marked congruent, and you have to have one leg being marked congruent. Okay, Pythagorean theorem kind of shows us why this guy works. That other leg right here, right here, those are always going to be the same because Pythagorean theorem is going to work out the same. So we're kind of using side, side, side or another shortcut, but here we go, HL. Okay, so let's flip it over on the back of our notes and kind of see what they're going to ask me to do with this. So they're going to say, maybe give us two triangles and say, like, what else do you need to be able to use HL to prove that the triangles are the same? On the first one, the triangles are connected. So you've got like the pink triangle right here and then the blue triangle over here. I want to show someone that those are the same and I want to use HL. Okay, these are right triangles. If that side is 90, that side's 90. That's how it works to make a line there. 90, 90 is 180. Okay, so I have the hypotenuse, which is what we said was like that first thing that we needed. Or I'm sorry, the right angle, which is the first thing that we needed. These are right triangles. Cool. Now, if you remember, when the two triangles line up like this, they actually share something. They share this middle side. They both have this side US on them. So that's good. If I think about like, is that the hypotenuse or is that one of the legs? That's one of the legs. So let's get my checklist going up here. They're right triangles. I have a leg that's congruent, so cool. We'll say congruent leg. Do I have congruent hypotenuse? Maybe make this a little bit neater on your notes here, guys. Do I have the congruent hypotenuse? No, I don't have that yet. All I have is a leg, so that's what else I would need here. I would need the hypotenuse to be congruent. So across from my 90, that's the hypotenuse. Kind of draw an arrow away from your right angle. That's what I need. So that's what I'm going to put on the line. I need TU to be congruent to VU. That's my hypotenuse. Cool. If I had that, I could use HL. All right, same checklist, different problem. All right, so let's look at this guy. The one on the right looks good to me. On the right, I have a right angle, check. Across from that, that has a mark on it, check. There's a leg. Okay, so it's got all the markings I like, but if you look at the one on the left, KLM, I don't even know where to start because I don't have the right angle. Like, I'm guessing that's what they want to be the 90. It looks like it. Then I would have, oh yeah, okay, hypotenuse are congruent. They've got two lines on them. Legs congruent. They've got one line on them. But the problem there is that's not a right angle. That's what I need to know. I need angle L to be a right angle. If that's good, then I'm like, yep, leg, hypotenuse, and okay, yeah, now they're both right triangles. Good to go. Okay, so you'll see something like that. They'll just be like, hey, what else do we need to be able to use it? So we'll have to practice that. Otherwise, we're going to see a lot of this, which we've seen this before. They're like, hey, which shortcut could you use? Or maybe none of them work. Then you just write not possible. So let's type in my options. Maybe jot this down on your notes, you guys. Here's your options. Let's get this bigger here. So you're thinking side, 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 angle, side, angle, or HL. That's our new one. If none of those work, you just say not possible. So those are my thoughts here. We're going to look at one at a time. Let's section this off. Okay, so A, two triangles. You got the one on top, you got the one on bottom. All right, let's see what we have. we have, and I'm going to actually mark what I can myself first. So the triangles share that middle side. They kind of match up right there. So I'm going to put a line on it to show that they have that part congruent. Now I'm going to label like angles and sides. Yes, these are right triangles, but you don't have to use HL just because it's a right triangle. So I'm going to look at the top one. I see an angle right there. In the middle, I see a side, and there's another angle that's marked. The bottom triangle has those exact same markings, so they're not trying to trick me there. I don't know if you guys can see this, but that's angle, side, angle. So yeah, I could prove these are congruent, ASA. That's my reason. On the next one, so I see these are also right triangles. I don't have to use HL, but if it works, I'm going to use it. Maybe you're not thinking HL. I hope you end up thinking it if you see a right angle. So if you were to go like, oh, there's an angle, side, side, angle, side, side. That's just ASS or that backwards. That doesn't work. Okay, so shift gears and be like, oh, cool, it's a right triangle. Does HL work? I don't know. Let's see. Whoop. So what do I need for HL? Well, I need them to be right triangles, which they are. Cool. I need the hypotenuse to be congruent. Okay, both hypotenuse have one little line on them. So check. And then one of the legs, the ones with two lines on it, those are congruent. So I have everything I need from that little checklist. HL proves that these are the same triangle. If you look at the next one, it's not a right angle, so I'm not going to even think about HL. I've got an angle, side, side. This is ASS or just SSA, which is the same thing. This one's not enough information. Same deal. I don't want to write that on my paper. Not possible. The order is not there. On the next one, I can mark these vertical angles myself. I'm going to do that right away. Do not forget to do that. Like we keep seeing that. Hopefully we're getting better at that. And now I'm going to go in and be like, okay, there's a side, angle, angle. In the other triangle, angle, angle, side. Okay, the order is the same. So just like look at one of them. SAA. That's the same thing as AAS. So yep, that guy works. Okay. Now, on to the proof. What I'm going to do, and again, I know we talked about proofs the other day, but you guys kind of lucked out. You don't have to fully write a proof and get all the writing to explain why two triangles are the same. We're going to go through this one together as a class tomorrow. So go ahead and hang tight on this example. We'll go through this together and I'll kind of recap HL. But you needed to do the rest of the notes and now go back to Canvas so you can finish the rest of the work for the day. All right, I will see you guys later.